Today we talk about the chapter 6 notes. Chapter 6 notes. Chapter 6 topic is a normal distribution. Normal distribution. Normal distribution is for the continuous number. Continuous number. The normal distribution is used by medical researchers to determine normal intervals for many variables. For example, the normal range of systolic blood pressure is 110 to 140. The normal interval for triglycerides is from 30 to 200 milligrams per deciliter, and these intervals can be used to decide whether treatment is needed to avoid future illness. Normal intervals are also used to determine lifetimes of batteries, strength of ropes, and many other traits. Property of normal distribution. The normal distribution curve is bell-shaped. Second, the curve is symmetric about the mean. The curve never touches the x-axis, but it gets increasingly closed. So normal distribution curve is bell-shaped. And mean here, standard deviation, and it's symmetric about the mean and never touch with the x-axis. And this gradually to the x-axis. And this we call bell-shaped, symmetric about the mean. Here's mean. Here's the mean. The curve never touches the x-axis, but it gets increasingly close to the x-axis. The total area under the curve is 1. The total area under this curve, the area is 100% probability. And empirical rule. Empirical rule. The area under the curve within one standard deviation of the mean is approximately 0.68, which is 68%. One standard deviation about the mean, minus one standard deviation, and the mean add one standard deviation. The area, one standard deviation, within one standard deviation of the mean is this area. And this area is 68% in empirical rule. And within two standard deviation is from mean, add two standard deviation, or the other side from mean minus 2 standard deviation. This area under the curve, which is this area, and that area is 95% from here to here, 95%. 2 standard deviation about the mean, and 3 standard deviation about the mean. It's from mean add 3 standard deviation, or from mean minus 3 standard deviation. This area. So the area from here to 3 standard deviation about the mean, and that total area under the curve from here, 3 standard deviation, and this area is 99.997, which is 99.7%. That's what we call empirical rule. empirical rule. And it's a normal distribution empirical rule. Then next, when a normal distribution has a mean of 0 and the standard, this mean, and that's we call z. If 0, here is 0, mean is 0, and the standard deviation is equal 1, and called standard, we call standardized. And use this formula, we can standardize to standard normal distribution. All the normally distributed variables can be transformed into the standard normally distributed variable z. So all the normal distribution variable x can, like here is x. If you use this formula, you can like x, if x is at a mean, then plug in here, mean minus mean is 0, divided z equals 0. So z equals 0. At this point, z equals 0 corresponding to mean. So can transfer into the standard normally distributed variable z. So x can transform to the z. Any normal distribution you can transform by this z-score formula. You can transform standardized, become z. Mean is 0. Z mean is 0. And the standard deviation is 1. Standard deviation is 1. And refer, that's the textbook page 324 to 325, for how to use the TI calculator to calculate the area under the normal curve, distributive curves using, and this is if you use using normal CDF, lower x value to upper x value, and the mean and the standard deviation. Important formula for chapter 6. First of all, z-score. Z-score equal x minus mean over standard deviation. And the z value for the central limit theory, that's the formula. Now, is x bar, which is a sample mean. X bar is sample mean minus population mean over standard deviation divided by square root of n. Sample size, it's n. Mean and the standard deviation for the binomial distribution, because we can use normal distribution to approximate binomial distribution when NP is so mean is equal n times p. Binomial distribution mean is equal n times p, and standard deviation is the square root of NPQ. Now here also you can see on your the formula sheet here, z-score, normal distribution z-score formula is z equal x minus mean over standard deviation. Mean of the sample mean is mean. This is x bar, means the sample mean. Mean of sample mean is the same as population mean, equal population mean. Standard deviation, also called error of the sample mean, is standard deviation of sample mean x bar is equal standard deviation, population standard deviation over square root of n. N is the sample size. I'll give you example. You can get better understanding for those formulas. Z value for the central limit theory, which is x bar, sample mean minus population mean over this is the sample standard deviation. So then we are going to cover those 4 formulas in this chapter 6. Let's see the first example. First example is if the first question, if those on the question on the notes is a similar question examples for your chapter 6 homework question. So those are examples for your chapter 6 homework question. First question, if the majority of the data value fall to the right of the mean, that means this is a higher fat, and this side is skinny. This side is a fatter. That means the majority falling to the right of the mean. Here has a mean. To the right of the mean is a fatter than the left side. Then the distribution we call skewed to the left. This side is skewed. Skewed to the left, also called negatively skewed. Because for real number, left side is for the real number to the left of 0 is negative, to the right of 0 is a positive. So left side is negative, right side is positive. So we call negatively skewed, also called left skewed, also called skewed to the left. Skewed to the left. And this kind, that's a symmetric. C is this kind, symmetric. And the other kind is skewed to the, is this. If the left side is fatter and the right side is skinner, this, and this we call, this is higher, so it has more data is here on the left side, and this goes skinner, so on the right side. And this we call skew to the right, also called positively skewed. So that is for A, and this is for B, and this is for C, symmetric. And for the normal distribution curve with a mean of 9, so this mean is 9, and standard deviation sigma equals 3. Which of the following range of the variable, this variable x, will define an area under the curve corresponding to approximately 34%. And this we call empirical rule. Empirical rule is one standard deviation above the mean. So 9 add 3. One standard deviation is 3, got 12. And 9 minus 3 got 6. So one standard deviation above the mean is 68%. So here is 68%. Since it's symmetric, 68% divided by 2. So this 34% total is 68%. And the two standard, so here approximately 34%. So will be from 6 to 9 or 6 to 12. So here the choice doesn't have a 6 to 9. 6 to 9 is 34%, or 9 to 12. So this is C. From 9 to 12 is 34%. 3 to 15. 3 to 15 is a 2 standard deviation, which is 95%. From 3 to 15, this area is 95%, is 2 standard deviation above the mean. 7.5. 7.5 it's here, and to 10.5. 9, 10, 11, 10, 11. So 10.5 is here, and 7.5 here, and this one you don't know how much percent. So this question is a C, from 9 to 12. Empirical rule. Then next question, the average weight of adult male bison in a particular federal wildlife preserve is 1,550 pounds. with a standard deviation. If you draw the curve, it's going to be like this. The mean is 1,550 pounds, and the standard deviation, this is a population, 280 pounds. Average means average weight means mean, and find the weight of an adult bull whose z-score is -1. So z-score equal -1. So use this z-score formula. Z equal to x minus mean over standard deviation. Then you do x minus mean equals z times standard deviation. You times sigma, both sides, z sigma. So this z-score equals x minus mean over standard deviation. So you times this sigma, both sides. And this sigma cancel. So you got it's a z times sigma equal x minus mean. Then you add mean, both sides. Then you will get it's x equal to mean add z times sigma. So then you can use this figure out and plug it in. So we got x equal mean plus z times sigma. So here, mean is 1,550 pounds. Add z-score equal -1, which is 1 standard deviation below the mean. So 1,050 minus standard deviation 280. So it's 1 standard deviation below the mean. This one is mean minus standard deviation. So this point is 1 to 70 pounds. So it's mean minus 280. That is 1 standard deviation below the mean. If the score is a -1, means 1 standard deviation below the mean. If a z-score is a +1, that's going to be 1 standard deviation above the mean. And question 4, find two z values from z1 and z2, two z values, and one positive. On the right side of the mean is a positive. At the mean is a 0. To the right is a positive. To the left it's a negative. There are equal distance from the mean, so that the areas in the two tails is 5%. The area at the two tails is 5%. So 5%, the two tail you add together is 5%. So you divide it by 2. Right tail, 2.5% is 0.025. Left tail, 2.5% is 0.025. Add together, total two tails is 5%. So each tail is 2.5%. Each tail is 2.5%. So this area is 0.028. And how to figure out, use z table, how to figure out this area, the z-score. So if you look at this normal distribution, standard normal probability, standard, and this they give this giving you the z here, giving you the z is to the left, this area to the left of this z-score. So for this question, given this area is 0.025, and you are going to find this corresponding z-score. Find out this z-score. So you have to look at this body. This body is about probability. 0.025 is about here. 0.0, this one. 0.025. 0.0250 is equal 0.025 without this 0 or have 0. They are equal. They are equal. So you look at this 0.025 is this one, this value, 0.025, this value. Go to the left, you got negative 1.9, and to the top is 0.06. The two put together, negative 1.96 is this value, 0.0250, this. That is negative 1.96 here. This one and this one. Crop intersection is when z equals negative 1.96, when this z value equals negative 1.96, the area to the left, this one is area is 2.5%, in decimal 0.025. So this is use the z table. You can find out this side is negative 1.96, and since it's a symmetric, equal distance, so this side you got negative, the other side you got positive. So answer is a positive negative 1.96. If you use the calculator TI-83 plus or 84 calculator, you key in, you press inverse normal key and press probability 0.025. Mu is 0, and key in mu equal mean is 0, and they will give you negative 1 point and rounded negative 1.96. And the other side, okay. Now that's then question 5. Find two z values such that 48% of the middle area is bounded by them. So this area is a 48%. So about the mean, the area is a 48%. So you draw a line and a normal curve, symmetric. And then in the middle here is the mean. Mean equals 0. To the left, to the right, figure out equal distance, z1 and the z2. This area, 48%. 48% divided by 2, so each one is 24%, 0.24. This 0.24. Total area is 0.48. And question asks you this z1 and this z2. Now, so we need to figure out this area, how much. You can do 1 minus 48%, 0.48, got 0.52. That is the two tails, the two sides. Then divided by 2, so you got each one. This area is a 0.26. This area is a 0.26. And here is a 48%. Total is 100%. 1 minus 0.48 and got 0.52. So this two area add together is 0.52. You divide it by 2. So this area is 0.26. This area also 0.26. And you can use table, figure out this z1. So you look at the table, you have to, because this table, this curve, and this is z, and this body is the probability, is to the left of z-score. Now here, this question is 0.26. So this should be 0.26. So you look at this body, find out 0.20 here, 0.26. 0.26 is very close to here. This is a 0.2611. This is a 0.2578. So 0.26 is closer to this one or closer to this one. If away from this is 11, away from this is 22, so it's closer to this. 0.2611 minus 0.26. The difference is 0.011. And the other one, 0.26 minus 0.2578. This one and this one. 0.2578. And you add 2 more 0. Subtraction. You borrowed. Get 10. Borrowed. Get 10. Subtraction. Get 2. 2. 0, 0, 0, 0. So this one is larger than this. So 0.26 is near to, closer to 0.2611. It's closer to this. 0.2611. Then you go to the left, get this. Negative 0.6. From this, go to the left, get negative 0.6. Go to the top, get 0.04. The two intersection is negative 0.64. The two intersection, negative 0.64. So this one, it's a 4 down to here, to the left, negative 0.60 up to 4. So you got negative 0.64, and that is this point. And since that's Z1, since it's symmetric, and so this side is to the left, it's negative, to the right, going to be positive, 0.64. So that's to Z score. Question 6. The average early bird special admission price for a movie is $5.81. $5.81. It's here. This $5.81. That's the mean. Given mean. This is the mean. If the distribution of the movie admission charges is approximately normal with a standard deviation. Standard deviation is 0.81. So this standard deviation is 0.81. The mean is 5.81. And what is the probability that a randomly selected admission charges is more than $3.5? So we're looking for probability of X more than $3.50. So we figure out this Z score, $3.50 Z score. So Z is equal X minus mean over standard deviation. And figure out this 3.5 Z score. So X is 3.50, plug in, minus mean 5.81 over standard deviation 0.81. The 2 subtraction is negative 2.31 divided by 0.81. And use calculator, you will figure out this Z score is negative 2.85. So this is a Z, and this is a negative 2.85. And use the table, you can figure out to the left of this Z score, this area, how much. So, and look at the table, negative 2.85 is here. Negative 2.85, negative 2, negative 2.85. Negative 2.8 here, negative 2.8. And here is negative 2.85. Negative 2.85 here. And the 2 intersection. This one is a probability. Now, negative 2.85, this intersection is 0.0022, is this area. This area is 0.0022, is to the left, because this table, this area, is looking for to the left of this z-score. So it's to the left of this negative 2.85. This area is 0.0022, is this area, 0.022. So to the left of negative 2.85, this area is 0.022, 0022. Now, so now you find this one. And then this question looking for probability of x greater than 3.50 after you standard transfer to z-score. X transfer to z-score. That's x is 3.50. When x is 3.50, translate to z-score. Corresponding z-score is negative 2.85. So probability when x greater than 3.50, that's equal probability when z-score greater than negative 2.85. So we're looking for this area, greater than to the right of negative 2.85, is this area. Since under the curve, total area is 1. So this area is equal 1 minus probability of this area. This area is when z is less than negative 2.85. So it's going to be 1 minus 0.0022. This area is 0.022, 0022. 1 minus it, you got this area, 0.9978. Because here looking for more than. So then question 7. A contractor decided to build homes, and that will include 80% of the market. Build homes, 80% will include 80% of the market. And if the average size of the average means mean size of the homes built is 1,810. So mean is 1,810 square feet. So this mean. And find the maximum and the minimum. Maximum and the minimum size of the homes the contractor should build. Assume that the standard deviation is sigma, this one. Standard deviation is 92 square feet, and the variable is normally distributed. 80%, and one include the contractor decide to build a home, that is include 80%. So this area it's 80%, and you need to figure out this minimum and the maximum, the size. So first of all, if this is a z, this is 0, and then here is 80%, symmetric. So you do 1 minus 80%, got 20%. So the 2 tails is 20%. Divided by 2, each tail is 10%. 10% is 0.10, 0.10. So use the table, you can figure out this value. The table, and the table, this area need to be 0.10. So 0.10, you look at the body, is the probability, is this area. The body, this body of the table is this probability area. Now looking for 0.10. So here, 0.1 here. And 0.10 is here. Is here. Between the two. Now, 0.10 away from 0.1003, you do subtraction, is 0.03. And for this one, 0.10 away from 0.0985. 0.10 0.10 away from 0.1003 difference is 0.003, and 0.10 subtraction. Borrow 1 is 5, borrow 1 get 9, borrow is this, is 0.095. So this is smaller. So 0.10 is closer to 0.1003. So it's closer to this one, 0.1003. And 0.1003, you look at to the left, is a negative 1.2. And you look at to the top, is a 0.08. Together is negative 1.28, is 0.1003 probability. This area is 0.1003. This z-score is negative 1.28. So we got corresponding z-score is negative 1.28. And since it's symmetry, the other side is positive 1.28. And then 80% will build the home, 80% of it. The minimum z-score is negative 1.28. Maximum z-score is 1.28. Translate to x value. Because the mean is, so this z-score formula, and you do z times sigma, add mean, get x. X equal mean plus z times sigma. So z times sigma equal x minus mean. So x will be equal mean minus z sigma. And plug in. Mean is 1,810. You add one standard deviation, 1.28, times the standard deviation is 92. And you times this, and you got maximum home size is 1,927.78 square feet. Minimum is minus 1,810 plus z-score, negative 1.28, plug in, times 92. And get minimum house size is 1,692.24 square feet. And that is, this is x. And this corresponding maximum, 1,927.78. And this corresponding to minimum, 1,692.24. And this is the mean. Mean is equal to 1,810. Standard deviation, it's 92. For this, mean is 0. Standard deviation equal 1. That's standardized. That's corresponding. So question 8. A survey found that the American family generates an average, which is average means mean, and 17.2. So mean is 17.2 pounds of glass garbage each year, average. And assume the standard deviation of distribution is 2.5 pounds. Standard deviation sigma is 2.5 pounds. Find the probability that the mean of a sample of 55 families, so n equal 55, n equal 55 families. Here n is 55 families, will be between 17 and 18. So find the probability how much percent the mean of a sample of 55. The sample size n is 55, n equal 55. So first of all, we will use this central limit theorem. For n, it's 55. So this is z equal x minus mean over standard deviation over square root of n. So first of all, figure out the 17. So 17 minus the mean is 17.2 over standard deviation given here, 2.5, divided by square root of 55. Then 17 minus 17.2 is negative 0.2 over 2.5. This reciprocal. So square root of 55 times on the numerator. And use calculator if you figure out is a negative 0.59. That's this point, z score, negative 0.59. Another one, when x is 18. So we are looking for probability when x is between 17 and 18. So figure out corresponding 17. It's a negative 0.59. So we are going to figure out corresponding x is 18. Z score is x is 18 plug in minus mean is 17.2 divided by standard deviation 2.5 divided by n sample size 55. And the 18.17.2 is 0.8 divided by 2.5 and reciprocal. So this square root of 55 put on the numerator. Multiplication, use calculator, figure out 2.37. So when x equal 18, corresponding 2.37 on z score. So we're looking for probability x go from 17 to 18 is the same as equal to probability when z score from negative 0.59 to 2.37. So from negative 0.59 to 2.37 and figure out this area. This is for z score. If we use the table, the table is given you to the left of z score. So it's the same as you do this one, this, and you are looking for the area from here to here between it. And this is z score. One is 0.51, and the 59. The other is 2.37. You can use the table to find out this area, because the table it's this area, and also use the table. You are able to find out this area, because on the table is looking for to the left of z score, and the two subtraction, which is this entire area to the left minus this entire area to the left, is going to be this area. So probability of the z between it is equal to probability of z less than 2.37 is to the left, this area to the left of 2.37, minus probability of this area, z less than negative 0.59. So you look at 2.37, z less than 2.37, you're looking for the table. On the other side is when z is positive, 2.57, 2.37, 2.3 here. This is a 2.3. This one, 2.3, and 7 is here. Their intersection is this one. 2.37 intersection. So the area is 0.9911. So that means this area to the left of 2.37, this is 0.9911. This area to the left of 2.37 is 0.9911, which is this area to the left, entire area. Then we are subtract this area. This area is when z is negative 0.59. So look at the table. Negative 0.59. It's here. Erase those. here negative 0.59, negative 0.5, this one, negative 0.59, 9 it's here, intersection, here, negative 0.5, on the top it's 9. So this is a negative 0.59, intersection is 0.2776. Negative 0.59, intersection is this, 0.2776. 0.2776 is this area to the left, this area. And this minus this is going to be the area between. So we do subtraction, and that is the area between it. 0.7135, change to percentage, move decimal to the right 2 position, is 71.35%. The question 9. A and B. The average means mean, annual precipitation for a large Midwest city is 30.85 inches.